So now we are starting with arithmetic progression and geometric progression review. In the syllabus, this is what is written about it. Recognize arithmetic and geometric progression. Use the formula for the nth term and for the sum of the first n terms to solve problems involving AP and GP. Third, use the condition for convergence. Let me highlight this. Use the condition for the convergence of a geometric progression and the formula for the sum to infinity of a convergent geometric progression. When we say an infinite series has a finite sum, this means we talk about sum to infinity. And what is the condition? The condition is common ratio should lie between -1 and +1. Of course, we are talking about a GP, nothing to do with AP. The second thing, this is known as convergence. Why it is called convergence? Because an infinite series is supposed to have an infinite sum. But if infinite series has a finite sum, that means the sum converges to a value. And that value is called sum to infinity. All good? So now let's get started. The first question, it says a woman's basic salary for a first year with a particular company is $30,000. Let's underline it. Basic salary, first year is 30,000. At the end of the year, she also gets a bonus of $600. Part A, for her first year, express her bonus as a percentage of her basic salary. So therefore, part A, that is 600 divided by 30,000 into 100. Cancel off the zeros, 1, 2, 3, 4, 1, 2, 3, 4. Therefore, we are left with 6/3, which is 2. So 2% is the answer. Now let's move to the second part. Now the second part, it says, at the end of each complete year, the woman's basic salary will increase by 3% and her bonus will increase by $100. Express the bonus she will be paid at the end of her 24th year as a percentage of the basic salary paid during that year. Now, first of all, there are two things over here. The first thing is, let's talk about basic salary separately. Let's talk about bonus separately. The first year, that means the first term, that is $30,000. And the bonus, the first term, that is $600. Then, when we talk about the basic salary, it will increase by 3%. So whenever percentage is involved, that is a GP. The common ratio is 1 plus R if it's an increase, 1 plus the percentage. 1 plus the percentage in decimals if it's an increase. R is 1 minus the percentage if it's a decrease. Since this is an increase, so in this particular question, R is 1 plus 3/100, which comes out to be 1.03. Let's talk about the bonus. Her bonus will increase by $100. So there is a $100 increase. That means this is an AP. So the common difference over here is positive 100. So this is the first thing that you need to realize. The percentage thing, that is trivial. That is secondary. Now it says express the bonus she will be paid at the end of her 24th year. So every year they're getting a bonus. It's not about the sum. It's about a particular term. At the end of the 24th year as a percentage of the basic salary. So that is separate. So what do you think we have to calculate? We have to calculate the 24th term of basic salary. We have to calculate 24th term of the bonus. So over here, A is $30,000. Common ratio is 1.03. N is 24. Tn is ARN minus 1. That is 30,000 into R, which is 1.03, n minus 1 is 24 minus 1, whatever that comes out to be. We will just look at the mark scheme. And then over here, A is $600, common difference is 100, N is 24, Tn is A plus N minus 1 into D. A is 600, N minus 1 is 24 minus 1 into 100, and this is the other answer. Now let me go to the mark scheme. Bonus is 600, 23 into 100, 2900. So I'll write 2900 over here. And the other thing, the salary, the basic salary, that is 30,000 into 1.03 raised to power of 23. This comes out to be 59207.60. 59207.60. And what are they asking? The percentage, the bonus as a percentage of the basic salary. For that, they made you calculate this trivial thing. So now the final answer is this thing, 2900 divided by 59207.60 into 100. Whatever the answer comes, that answer should be in percentage. Now this comes out to be 4.9%. Now look at this thing. They have written 59200. In my view, this is their 59200. That means they have used this value. You people must have used some other value. So officially, you should use unrounded 4 significant figure value. Even if you use this many significant figures, that's not an issue. This is perfectly fine. So now this question is done. Let's move to the next one. Now the question says, the sum of the first 9 terms of an AP is 117. The sum of the next 4 terms is 91. And it's asking for find the first term and the common difference of the progression. So first of all, it's an AP. And A is unknown, D is unknown. That means it's a simultaneous equation question. Now, S9, that is 117. S next 4. Next 4 after 9. What is that? That is basically 10th, 11th, 12th, and 13th. The sum of these 4 terms is 91. Now, remember when we studied AP, we did a book question in which the sum of the first 6 terms and the next 4 terms. So there were 2-3 different approaches that we tried. Let me first focus on this. Approach 1 or method 1, that is T1 till T9 and T10 till T13. So this is 13. So I can add this and I can say sum of 13 terms is 117 plus 91. That is the most direct approach. Method 2, that is add up the terms individually. So you can say T10 is A plus 9D. T11, that is A plus 10D. T12, that is A plus 11D. T13, that is A plus 12D. And if I add this, therefore, sum of next 4, this comes out to be 4A. 9, 11 becomes 20. 10 plus 12, that becomes 22. So 20 plus 22 is 42. So this is 42D, and this comes out to be 91. That is the second approach. Of course, you also have this third approach. I'm not going to use it, but I'm just writing it down. That is sum of 13 terms numerically, symbolically, minus sum of first 9 terms will give me sum of next 4 terms. So that is also an option. I think I would prefer to use either method 1 or method 2. So let me just write down the equation. This is Sn, 117 is n divided by 2. Even before that, let me write the official formula. So that is Sn is n divided by 2. 2a plus n minus 1 into d. So this is 117, 9 divided by 2. 2a, 9 minus 1 is 8d. This is equation 1. And over here, I already have the equation. So the purple equation, that is 4a plus 12d, 42d. 4a plus 42d is 91. That is equation 2. We solve simultaneously. We find the value of a. We find the value of a. Let's double check. 117 is this thing. That's the first one. Either 91 with S4 with a as a plus 4d, or 117 plus 91. I mean, that's the whole thing. The final answer is this. All good. Next one. Why don't you go ahead and try this question? So now let's look at the other question. That is this one. I'll solve it for you first. The question says the nth term of an arithmetic progression is this thing. So for this particular question, they have defined Tn themselves. That is half 3n minus 15. If we want, we can even take more common out. That is 3 over 2, n minus 5. Now it says find the value of n for which the sum of the first n terms is 84. Now it's a good question. Now, usually in this kind of question, let me add what they are missing. That is, find the first term and common difference. That is usually the question. Let me solve that question first. N is 1, T1, that is 3 over 2, 1 minus 5. That is negative 4, that is 3 over 2 into negative 4, 2 ones are, 2 twos are, that is negative 6. Let me plug in n is equals to 2. T2, that is 3 over 2, and this is 2 minus 5. That is 3 over 2 into negative 3. That comes out to be negative 4.5. Now keep in mind, when n is 1, what you are getting is term 1, that is negative 6, and this is the term formula. Usually the question is about the sum formula. This time it's about the term formula. T1 is negative 6, T2 is negative 4.5. So negative 6, negative 4.5, what is the common difference? The common difference is coming out to be positive 1.5. So we have first term, that is negative 6. We have common difference 1.5. Find the value of n for which the sum of the first n terms is 84. So Sn is equals to 84. 84 is n divided by 2. 2a n minus 1 multiplying with d, which is 1.5. So therefore, 168 n minus 12, 1.5 n minus 1.5, n negative 13.5 plus 1.5 n. That is 1.5 n square minus 13.5 n is 168. And then we simplify and solve this quadratic equation. So when we solve this quadratic equation, n, it is necessary, has to be a positive integer because n is the number of terms in the series. Now let's double check the answer. First term negative 6, second term negative 1.5, d is 1.5. This is the simplified form, 3n square minus 27n minus 336. The value of n is 60. All good? The next question, something to do with trigonometry. And this is about, excuse me, convergent, and so all these things. The first term of a progression is sine square theta. Theta lies between such and such. The second term of this progression is this much, part A. Given that the progression is geometric, find the sum to infinity. So let me first copy this and paste it on the next page because I'll be needing it. Now over here, T1 is sine square theta. T2 is sine square theta, cosine square theta. And naturally, you know that the first one is A, the second one is AR. So what is R over here? Cos square theta. So therefore, A is sine square theta, R is cos square theta. And what else are they asking? The second term is this thing. Given that the progression is this thing, find the sum to infinity. Sum to infinity is A over 1 minus R. What is A? Sine square theta. What is R? cos square theta. This is 1 minus cos square theta, which is sine square theta. So it's a sweet little question. And this comes out to be 1. That is the sum to infinity. Acha, why do you think they have written this thing? Maybe that in the first quadrant, sine is positive, cosine is positive, maybe something because of that. Now it says it is now given that instead that the progression is arithmetic. So let me go to the next page. Progression is arithmetic. Everything else remains the same. Part 1, find the common difference of the progression in terms of sine theta. T1 is sine square. T2 is sine square, cosine square. If you don't want to write everything, just take the examiner into confidence and explain to them that sine square is written as s square, cosine square theta, it's theta, yeah, it's written as c square. So therefore, the common difference is T2 minus T1, which is sine square, cosine square minus sine square common, cosine square minus 1. Now, don't be in a hurry. We know that sine square plus cosine square is 1. Sometimes we make sine square the subject, which is 1 minus cosine square. Sometimes we make cosine square the subject, which is 1 minus sine square. But this is the opposite. This is cosine square minus 1. So therefore, what should I write? Minus sine square. And this is sine square already. And they want the answer in terms of sine. So this is negative sine power 4 theta. That is the answer for this one. Now it says find the sum of the first 16 terms when theta is pi by 3. I think now it's about exact form. So B part 2, sine of pi by 3 is root 3 over 2. Cosine of pi by 3, I'm just writing it. Cosine of pi by 3, that is half. We are interested in the sum of first 16 terms, and this is an AP. Sum of n terms, that is n divided by 2, 2a, n minus 1 into d. Now, what is a? A is sine square theta. So let me write over here, a is sine square, and this is pi by 3. So that means sine of pi by 3 whole square. That is root 3 over 2 whole square. That comes out to be 3 over 4. That is a. And what is d? D is negative sine power 4 theta. D is negative sine pi by 3 raised to power of 4. This is negative sine of pi by 3 is root 3 over 2 power 4, which is, excuse me, 3 over 4 whole square, which is 9 over 16, negative 9 over 16. So now n is, I think, 16. Yeah, n is 16. 16 divided by 2, 2a, 2 into 3/4. N minus 1 is 16 minus 1, which is 15. And d is negative 9 over 16. Now it's just usage of calculator. And then that's how you get the sums. All good? Now, next one. I would like you people to try it out first. So now let's look at this question. The question says, a GP has first term A, common ratio R, sum to infinity S. Then there is a second GP. It has first term A, common ratio capital R, sum to infinity 2S. Now, first of all, I need to pinpoint what is common, what is uncommon. A is common. This is S and this is 2S, that's common. What is uncommon? There is small r over here. There is a capital R over here. So now, first of all, I'll write GP1. First term is A, common ratio is R, sum to infinity is capital S. Then there is GP2. First term is A, common ratio is capital R, sum to infinity is 2S. First part, I'll do the first part first. Show that R is this. Sum to infinity, A over 1 minus R. Sum to infinity is 2S. That is A over 1 minus capital R. So what I can do is that I can make A the subject. So if I make A the subject in both S bracket 1 minus R is equals to A, 2s bracket 1 minus capital R is equals to A. S bracket 1 minus R is equals to 2s bracket 1 minus capital R. So now I can slash off the S. 1 minus R is 2 minus 2R. I have to make small r the subject. So therefore 1 minus 2 plus 2R is equals to small r. So small r is R minus 1. Is that the answer? 2R minus 1. My bad. This is 2R minus 1. So this is the answer. Now, let me copy this. Copy and paste. Now it says that it is now given that the third term of the first progression is equal to second term of the second progression. So first of all, let me write GP 1. Why is it missing? GP1 A small r capital S. And then over here GP2 A capital R and 2S. And we have proven that small r is equals to 2R minus 1. Keep that in mind. Now it says the third term of first progression. So T3, that is AR square, that is A as it is, and R is 2R minus 1 whole square. And then the second term of second progression, T2, that is simply AR, that is A into capital R. So this R is basically this R. They are equal. So if I equate them, A bracket 2R minus 1 whole square, that is A into R. It says express S in terms of A. So if I cancel this out, and this is 4R square minus 4R plus 1 is equals to R. 4R square minus 5R plus 1 is equals to 0. So that is 4R square minus 4R minus R plus 1 is equals to 0. 4R common R minus 1. Minus 1 common R minus 1 equals to 0. R minus 1. 4R minus 1 equals to 0. Therefore, R is positive 1. Therefore, R is 1/4. It says express S in terms of A. Now, first of all, this needs to be rejected, because if the common ratio is 1, all the terms are lookalike. So R is equals to 1/4 except this thing. Now, what needs to be done? If I have R as 1/4, I need S. So S is this one, right? So therefore, I just need some more space. S is A over 1 minus R. That is A over 1 minus 1/4. 2S is A over, no, I'm using this. So now S is A over 1 minus the small r. Yeah, I'll just use. Hold for a second. So A, either I can use this or I can use this. Since I have R, let's use this. So 2S is equals to A over 1 minus R. 2S is equals to A over 1 minus capital R. That is A over 1 minus 1/4. A over 3/4. That's 4/3 A. That is 2S. Therefore, S is divided by 2. That is 2/3 A. S is 2/3 A. Sahi hai? Now, let's look at this one. Let me go ahead and now solve all these questions as much as possible. The first, second, and third term of a GP are such and such. So in a GP, common ratio is the same. Common ratio is T2 over T1. That is T3 over T2. So common ratio is negative 2P divided by 2P plus 6. Common ratio is also P plus 2 over negative 2P. P is positive. That means we will end up with a quadratic equation. We'll get more than one values. We will have to discard one and choose the other one. So minus 2P into minus 2P. That is minus 2P square. This is P plus 2, 2P plus 6. So therefore, this is 4P square This is 2p square plus 6p, 6p plus 4p plus 12. That is 2p square plus 10p plus 12. This is 4p square. It's divided by 2. That is your first subtract. 2p square minus 10p minus 12 equals to 0. P square minus 5p minus 6 equals to 0. P square minus 6p minus p minus 6 is equals to 0. Minus 6p plus p. P common, p minus 6 plus 1 common, p minus 6 equals to 0. Therefore, p is 6. Therefore, p is negative 1. So now again, discard, again, reject. Accept, p is equals to 6. Reject, p is equals to negative 1. Find the sum to infinity of the progression. So now, when r is equals to positive, when p is equals to positive 6, r equals to p plus 2 over negative 2p. That is 6 plus 2 over negative 2 into 6. That is 8 over negative 12. That comes out to be negative 2 over 3. This is r. What is the first term? 2p plus 6. First term, 2p plus 6. 2 6 are 12. 12 plus 6 is 18. So therefore, sum to infinity, that is a over 1 minus r. That is 18 over 1 minus 2/3, which is 18 over 5/3, which is 18 into 3 divided by 5, whatever that comes out to be. Okay, so that finishes this question. Yes, this question, let's have a look. So now it says the sum of the first n terms of an arithmetic progression is given by such and such. Sn, that is n square plus 4n. The kth term in this progression is greater than 200. Find the smallest possible value of k. Now, this question is exactly like the one that we solved earlier. That was the term formula was given. Over here, the sum formula is given. So what we will do is that we will write n is equals to 1. Sum of one term is 1 square plus 4 times 1, which is 5. Let me plug in n is equals to 2. Sum of two terms, that is 2 square plus 4 into 2. 4 plus 8, that is 12. Now keep in mind, sum of one term is basically T1. Sum of two terms is T1 plus T2. The difference between these two is the second term. So T2 is 7. So now rewrite it again. So now I'll write 5 as the first term, 7 as the second term, and so on. It's an AP. Yes, it's an AP. So first term is 5 and common difference is 2. Now it says there is a particular term, the kth term, and that kth term that is equals to, is greater than 200. So like nth term, for simplicity, let me write this thing as nth. So nth term is greater than 200. A plus n minus 1 into d, that is 5 plus n minus 1 into 2. So that is 5 plus 2n minus 2, that is 3 plus 2n. So this is 3 plus 2n. So Tn is greater than 200. Let me erase this step. I'm simply writing Tn over here. Now Tn is greater than 200. 3 plus 2n is greater than 200. 2n is greater than 200 minus 3. 2n is greater than 197. N is greater than 197 over 2. How much is this? 190, that is 95? 98.5. Therefore, you pick the next integer. So n comes out to be 99. So n comes out to be 99. K comes out to be 99. Okay, over here, I think this is power 7. It's slightly erased. It says in the expansion of a plus b raised to power of 7, where a and b are non-zero constants, the coefficient of x, x squared, and x4 are the first, second, and third terms of a geometric progression. So this time they have mixed binomial with APGP. So now let me first write a plus b raised to power of 7. If I'm not mistaken, this is 7. I can check in the original one, but I think it seems that, yes, it is 7 because they have gone till x4 anyway. So now I can write particular terms. I can do the expansion. Let me do the expansion. That is 7c0. 7C1, and then I'll pick the relevant terms, 7C2, and then 7C3, 7C4. I think that is all what I need for right now. Why? Because there is the BX term. So that means the powers are increasing. So over here, I'll write A in the first bracket, and then I'll write B in the second bracket. And what about the powers? This is 0, this is 1, this is 2, this is 3, this is 4. It's not just B, it's BX. It's BX. And then the powers of the other would be 7, 6, 5, 4, 3, and so on. Now we are interested in the coefficient of X. So let me first focus on that. Coefficient of X, which one is that? That is this one. That is 7C1, A power 6, B power 1. And then I'm interested in X squared and X4. Coefficient of X squared, coefficient of X4. So coefficient of X squared is which one? That is 7C2, A power 5, B raised to power of 2. Coefficient of X4, that is 7C4, A power 3, B power 4. So now, first of all, 7C1 is 7. That is obvious. 7C2 is what? 21. What is 7C4? 35. Okay. Now I need to write it again. So this is 7A6B. The other one is 21A5B squared. Then 35A cube B4. So these are the first three terms, respectively, of a geometric progression. Find the value of A over B. Now what we can do is that, again, this is T1, T2, T3. So first of all, common ratio, T2 over T1, 21, A5, B square over 7, A6, B. This is 3. There is a at the bottom, and there is a B at the top. Okay. Common ratio again. So now this is 35, A cube, B4, divided by 21, A5, B square. 7 5s are, 7 3s are, A square at the bottom, B square at the top. Now they both are common ratio. So now equate 3B over A. That is equals to 5 over 3 B square over A square. I need what? I need A over B. So if I need A over B, let me write A square. And A is there. Let me write B over here. There is B square. This is 5 into 5 over 9. So therefore, this is A is left and B is left. So therefore, A over B is 5 over 9. If I'm not mistaken, yes, that's the answer. So it's just usage of binomial to form this thing. Okay, one other question like this. The first, second terms of an arithmetic progression. So let me highlight it. So this is first and second. Arithmetic progression are such and such. Theta lies between this thing. Part A, show that the common difference is this thing. So first thing is T2 minus T1 is the common difference. That is negative tan square. Let me first simplify this. So first of all, T is S over C. T square, S square over C square. T square divided by C square. T square is S square over C square. Division by C square, multiplication by 1 over C square, which is S square over C4. So this is S square over C4. That is T2 minus 1 over C square is equals to D. So now let's take LCM. That is C4. S square remains as it is. And there is a C square over here. That is D. Did I miss the negative sign? Yes, there is a negative sign. And there is a negative sign. And minus common, 1. S square plus C square is 1. Divided by C4 is equals to D. So D is negative 1 over C4. Is that the answer? Yes. Now, the second part, let me just copy this. Let's move to the next page. Now it says the second thing, that is, find the exact value of the 13th term when theta is pi by 6. Now, first of all, theta is pi by 6. First term is 1 over cosine pi by 6 whole square. What is cosine of pi by 6? That is root 3 over 2. So squaring would be 3 over 2. So therefore, this is 1 divided by 3 over 2, which is 4. Thank you. So this is 3 over 4 after the squaring, and that comes out to be 4 over 3. When theta is pi by 6, common difference is negative 1 over cosine of pi by 6 whole power 4. This is negative 1 over, this 3/4 will become 9 over 16. Flip it, that comes out to be negative 16 over 9. And T13, that is A plus 12D, n minus 1, that is 12D. A is what? That is 4 over 3. 12 as it is, negative 16 over 9, simplify, and then you get this answer. I don't know why it has to write exact form, because it is coming out to be an integer. I don't know. That completes the AP and GP review.